In our last video, we did introduce projectile. Now, I want us to look at the quantities that we can determine under projectile. Then, I told you in the last video that a body can be projected either vertically or horizontally from a height, or a body can be projected at an angle to the horizontal. So we are going to consider the three possibilities. When a body is projected vertically, the quantities we can determine is number one, time to reach maximum height. Time to reach maximum height. And time to reach maximum height is represented with small letter t. Okay, now if we recall, under our equation of gravitational motion, the first equation we said that v equals u plus or minus gt. The second equation we said that mh equals ut plus or minus half gt squared. And then the third equation we said v squared equals u squared plus or minus 2gh. So these three equations of motion are going to guide us to determine the quantities needed for a projectile at every point. Now, when a body is projected vertically upwards, you remember that this plus or minus, I said, we do not use the two of them at the same time. It is either plus or minus, and we make use of minus when the body is going upwards. We make use of plus when the body is coming down. So if we take note of that, now this body projected upwards, time it will take the body to go from a point, from this point A to this point B, is what we want to determine. At point A body was projected with a certain velocity u, that is the initial velocity as we always represent, and when it gets to this maximum height, that is the final velocity v at that point. Okay, so we are looking for the time it took the body to go from A to B. If you look at, we have u, we have v, and we are looking for time, you see that the first equation will be able to help us get that. So taking note of that, we will take v equals u. We are going to use minus because the body is going up, so it's going to be v equals u minus gt. And if that is the case, we'll try to make t the subject of the formula. So knowing that when a body is projected upwards, I've always told us that at maximum height, a body comes to rest momentarily before it begins to come down. So at this maximum height, the body comes to rest, and at that point, the velocity is 0. So it therefore implies that v is equal to 0. So if we take that into consideration, we have that 0 equals, substituting in this equation, u minus gt. And if gt should cross the sign of equality, in order to make t the subject of the formula, we'll have gt equals u. Okay, and then when we proceed further, we divide both sides of the equation by g, and then g here will cancel g here. So the time that it will take the object to go to its maximum height is u all over g, where u is the initial velocity of projection and g is acceleration due to gravity. Another quantity that is very important we need to know is the time of flight. Time of flight. Time of flight is the time spent by the object in air. If the point of projection is level, if it is a level point of projection, then a body projected to a certain height will come down to the same level of projection. And if that happens, initial velocity, we said that the time it took the object to get from this point to that height is u over g. So it will still take the object the same t, small letter t, to get from that height down again. Time of flight is represented with capital letter T. So one can comfortably say that time of flight is twice time to get to maximum height, if the point of projection is level. Okay, so if that is the case, it therefore means that time of flight is equal to 2u over g, since time to get to maximum height is u over g for a body projected vertically. Okay, we also have to determine the height. That is another very important quantity we need to determine, the maximum height of a projectile. The maximum height. Okay, at maximum height, represented with capital letter H, to differentiate it from other heights. At maximum height, which of the equation is going to help us? From the three equations of motion we have, we realize that the first one, which we use, v equals to u plus or minus gt, will not be able to do that because there is no height in the equation. So we can either use equation 2 or equation 3 to get to give us a maximum height. Okay, if we use that, we can use equation 3. It will be simpler for us to use equation 3, which says v squared equal to u squared minus, we are using minus because to get to maximum height, the body is going up to gh, and then h, we use capital letter here, and we will try to make h solid for formula. Remember that at maximum height, the final velocity is 0. So we have 0 squared is equal to u squared minus 2gh. And if that is known, we can move 2gh to the left hand side of the equation so that it becomes positive. And then we have 2gh here is equal to u squared. And if we do that, we can divide both sides by 2g so that the height will be left alone. We divide both sides by 2g. 2g here will cancel 2g here. And then the height, the maximum height, is equal to u squared all over 2g. So with that, we have been able to get the time of flight, time to get to maximum height, and maximum height. This is the time of flight, t equals to u over g. The time to get to maximum height is this, t equals to u over g, and then the maximum height is u squared all over 2g. Another important quantity in projectile is the range. But for a body projected vertically, you will realize that if a body is thrown vertically upwards, it goes up and comes back through the same paths of projections, provided it is vertically. And if a body goes up and comes down through the same path, there is no range, because range is the horizontal path covered by the projectile, trajectory of the projectile. So if a body goes up and returns through the same path, there is no range. Therefore, the range for a projectile, a body projected vertically upwards, is equal to 0. So we take cognizance of that. So having known these quantities for a body projected vertically upwards, let us look at the relation for a body projected horizontally. Okay, if a body is projected horizontally, remember I told you that in a horizontal projection, it must come from a certain height. It cannot come from the ground. So a horizontal projection must come from a height. If a body is projected horizontally from this height, it will definitely move a bit before it will start falling, because gravity will start acting on it. And when that happens, you see that the quantities we can determine here is the horizontal distance, which is can refer to as the range. We can also determine the vertical distance, which is the height. And then the initial velocity of projection here is the velocity, the horizontal component of the velocity, and the vertical component of the velocity of initial velocity will be 0, because at this point there is no vertical component acting on the projectile. It is only the horizontal component. It is when it starts coming down that both horizontal and vertical begins to act on it. So what then are we going to do? What we are going to do is to use the same equation of motion. And then, very important in this particular aspect of projectile, I will always advise students to make use of the second equation of motion. It can to help you solve anything you want to solve. The second equation which says h equals ut plus or minus half gt squared. So if we make use of this second equation, it will help us do whatever thing we want to do in horizontal projection. Now, what do I mean? If I want to determine the maximum height of projection, and at maximum height of projection, when you are considering the vertical component, not the horizontal component, and we said that if we say the vertical component, that means u is the vertical component of initial velocity. And I said that at initial velocity here, it has only horizontal component, there is no vertical component. And because there is no vertical component, it means that the vertical component is going to be, this is plus because the body is going to be coming down, half gt squared. So at that point, the vertical component of the initial velocity is 0 because it has only horizontal component. But why are we using vertical component? Because we want to determine height. Height is vertical. If it is range we are interested in, then we make use of the horizontal component, as the case may be. So if that is the case, in the vertical projection of a body, we didn't talk about anything about horizontal component because only vertical happened. But here in a horizontal projection, both horizontal and vertical happened because it will move horizontally and then come down vertically. So we are going to consider both scenarios. So at vertical, initial velocity at vertical is 0. The initial velocity at horizontal is the maximum velocity of projection. Then when it is coming down, it begins to possess both horizontal and vertical. And remember, the horizontal component of the velocity is a constant and does not change. But as the body is falling, the vertical component begins to increase from 0. So the vertical component initial velocity is 0. So if that is the case, it means that the ut becomes 0. So the height, the maximum height for a body projected horizontally is just going to be represented by half gt squared. So this is the formula you should be using whenever you want to determine the maximum height for a horizontal projection. Okay, then if you want to determine another quantity, we can determine, of course, this same formula is going to be used to determine the time for a body to move from that maximum height to the ground. Okay, we use this and make t the subject of the formula. If we do that, we are going to have that t is equal to 2h all over g and then the square root of that. This is the time it will take the object to move from that maximum height to the floor. Remember, the body was at a height, it didn't come from the floor, so there is no upward movement, we only have a downward movement. So another thing we can determine is the range using the same formula, h equals to ut plus half gt squared, but h this time around will be represented with r. Remember, that h is a height and could also be referred to as a distance. So if we consider horizontal motion, it means since the range is horizontal, it means that this u will be u of x, the horizontal component of the initial velocity, and then the time plus half gt squared. Since it is range we are considering, at horizontal motion, the acceleration due to gravity does not affect the horizontal motion of a body. So at horizontal motion, at horizontal, g equals to 0, and if g is equal to 0 at horizontal, then r will be equal to just the horizontal component of the velocity times time. It means that if g is 0, everything here becomes 0. So this is the formula we use to determine the horizontal distance covered by a projectile if the projectile is thrown horizontally from a height. Okay, we have gotten the three quantities we need: the maximum height of a horizontal projection, the time of horizontal projection, and the range of horizontal projection. We can also say that the time of horizontal projection is equal to the range all over the horizontal component of the velocity. This can also be used to get the time. So whenever you want to determine the horizontal components, horizontal quantities, these are the formulas we are going to use. This one for height, this one for range, and either this or this for time, depending on what you have as your parameters. So if that is the case, we are done with the quantities needed, or quantities that you can be asked to determine when a body is projected horizontally. Then let's look at when a body is projected at an angle. That is also very important. So when a body is projected at an angle, you have this kind of trajectory. If a body is projected at an angle to the horizontal, this is theta, the body will go this way and return this way, and this is the velocity of projection. This velocity of projection is neither horizontal nor vertical because it is in between horizontal and vertical, and that means that at every point of this trajectory we have a horizontal component. So at this point we have the initial vertical component, which is uy, we have the initial horizontal component, which is ux, and at every point of the trajectory we have both the horizontal and the vertical components of the projection. So this is vx, this is vy, and then we have a maximum height, okay, as we have described before. We also have a range, as we have described before. So those quantities that we got in the other ones, we are going to get it here again. So if we look at time, it takes the object to get to maximum height. Time it will take this object to get to this maximum height. We use the first equation of motion, of gravitational motion, to get it the other time. We are still going to use it. V is equal to U minus GT, minus because to get to maximum height, the body is going up. So if that is the case, this is what we are going to use. But you know that at a height, that is a vertical motion, this V is going to be the vertical component of the velocity, this U is going to be the vertical component of the velocity, and then minus GT. Okay, and at maximum height, that is the final velocity, is 0, so we'll have 0. Then UY is the vertical component of the initial velocity, but you know that what we have is U, not UY. But if we are to resolve this U to the vertical using vector resolution, we are going to have U sine theta. That becomes the vertical component of the initial velocity. So this U sine theta is the same as that UY minus GT. And then when we move to GT to the left hand side of the equation, we'll have GT equals U sine theta. And then when you divide both sides of the equation by G, divide both sides of the equation by G, G will cancel G. So the time to get to that maximum height will be U sine theta over G. Okay, and not to bore us with how we get the other ones, if a body is projected at an angle from a certain point, and the ground is a level ground, that is, it is a level ground, so that the body will return back to the same level of projection, then time of flight is twice time taken to get to maximum height, and time of flight is the time spent by the body in space, in air. So if we take that, the time it will take the object to get to this point will be the same time it will take the object to move from this maximum height down to the same level of projection. So the time of flight is twice the time taken to get to maximum height, and we got the time to maximum height if a body is projected as an angle as U sine theta over G. You realize that the difference between what we have here and what we had when a body was projected vertically is that there was no sine theta in that of vertical, because the angle of projection for vertical projection is 90 and sine 90 is 1, so that is why T is equal to U over G there. But here the body is projected to the horizontal, to the projected at an angle to the horizontal that is not 90, so that is why sine theta had to appear. So the time of flight will become U, 2U, twice of U sine theta over G. So we have 2U sine theta over G. So this is the time it will take the object to get to a maximum height and return to the same level of projection, which we call time of flight. Another quantity we determine there that we are going to determine again is the maximum height. What is the maximum height? If we follow what we had there, an equation, which equation are we going to use this time around? We can use equation 3 as well, just like we used before, that V squared equals to U squared minus 2GH. So to get the maximum height, we are going to make H subject of the formula. And remember, for maximum height, we still use the vertical component, which is V squared equals to U for Y squared minus 2GH. And at maximum height, the velocity is 0. Final velocity is 0. So 0 squared equal to the horizontal component, the vertical component of the initial velocity. And the vertical component of the initial velocity, if we are resolving U to the vertical, is going to be U sine theta. And of course, it is going to be squared because this is squared, minus 2GH. So if we move 2GH to the left hand side of the equation, we have it will change to positive. If you remove minus 2GH, it will change to plus 2GH equals to U. If you square U, you have U squared. If you square sine theta, you have sine square theta. Okay, then we are going to divide both sides of the equation by 2G to make H the subject of the formula 2G, so that this 2G we cancel this 2G, and then we have that maximum height is equal to U squared sine square theta all over 2G. So if that is taken into consideration, this is the maximum height of projection for a body projected at an angle. Remember that of a body projected vertically upwards is U squared over 2G, but here we're having U squared sine square theta over 2G. So sine is only appearing because it is projected at an angle that is not 90 degrees. That is not vertical projection and not horizontal projection. Another quantity we determined was the range, which we are going to determine again, the range using the same equation. Okay, if we use the same equation, you know, or let's use equation 2. We use equation 2 that says that h is equal to ut plus or minus half gt squared. We know that since it is horizontal component we are considering, we are going to use the horizontal version. Okay, so the h is going to be what? U for horizontal, that is ux, and then t is going to be time of flight because we are considering range. Range is the total, the up and down of the projectile, so it is the time of flight. Okay, plus or minus, you can use both plus or, because the body went up and still came down, half gt squared. But since the body, we are considering the horizontal component, since this height h now is going to be r, it means that the acceleration due to gravity is 0 because gravity does not act horizontally, instead it's vertical. And if g is 0, everything here becomes 0. So we have that r is equal to ux t, just like we got when a body is projected horizontally. But you know that this us, we are going to get the horizontal component. You know that the horizontal component of a projectile, if you resolve u to the horizontal, you have u cos theta. And if you have that, then remember this time of flight, we have already gotten time of flight to be 2u sin theta all over g. Okay, and then if we put these two things together, we're going to have that the range is equal to u times 2u. You have a 2u squared sin theta cos theta all over g. And you recall that there is a trigonometric relation that sin 2 theta is equal to 2 sin theta cos theta. So if we know that relation, then we can now say that our range can be rewritten as, you make these two to join this, so that I have u squared 2 sin theta cos theta all over g. So these 2 sin theta cos theta, we can replace this with sin 2 theta, so that our range becomes r equals u squared sin 2 theta all over g. So this is the range when a body is projected at an angle. So with this, we have gotten the four quantities: the time of flight, time taken to get to maximum height, the maximum height, and the range for when a body is projected vertically, when it is projected horizontally, and when it is projected at an angle to the horizontal. So another very important quantity we should note is that we have the maximum, what we call the maximum range. A body will have its maximum range when the angle of projection of that body is 45 degrees. And that means that from the formula of range, which we said range is equal to u squared sin 2 theta all over g, if we substitute that maximum range, we are going to have u squared sin 2 times 45 all over g. And if that is the case, maximum range will be equal to u squared sin 90 all over g, and sin 90 is 1, so therefore maximum range is equal to u squared all over g. And this is the formula to determine range when it is a maximum range. Okay, so denote that as a very important quantity to take note of. So let's look at this one question. It says a particle is projected horizontally at 10 meters per second. Says solution. The particle is projected horizontally. Let us create a diagram first. It's projected horizontally. That is, the initial velocity of projection is 10 meters per second. Of course, this is the trajectory of that particle. Okay. From a height of 45 meters, the height of projection is 45 meters. Calculate the horizontal distance covered by the particle before hitting the ground. Calculate the horizontal distance, let's call it range, covered by the particle before hitting the ground. Okay, you remember what we just did, that r, if it is horizontal, is ux times t. Okay, and then to get this r, ux is the horizontal initial velocity which is 10 meters per second. So this is the horizontal initial velocity, 10 meters per second, but we do not know what time is. We are looking for range, we do not know what time is, but we know the height. But we know that the formula to determine height from what we just discussed is half gt squared. Okay, so if that is the case, if this is the formula to determine the height, then we know the height, we know the acceleration to gravity. We can use this other formula to get the time, then substitute here and get our range. That is how we solve that. I said these two formulas is what you'll be using when a body is projected horizontally, either to get the range or to get the height or to get the time. So if you are just given a question on projectile for a horizontal projection, just call up these two formulas and you will be able to solve it. So if that is the case, let us see, the height is 45 meters, so we substitute 45 meters equals half times 10 meters per second squared, which is the acceleration to gravity, times time squared. Okay, and if these two we give this, or we cross multiply, if we cross multiply we'll have 90 meters equals 10 meters per second squared times t squared. Since it is t we are looking for, we are dividing both sides of the equation by 10 meters per second squared, 10 meters per second squared. Okay, and this 10 meters per second squared will cancel this 10 meters per second squared. Meter will go with meter here, 0 will cancel 0 here. So we have that t squared is equal to, what is remaining here is 9, and per second squared is when it goes up it becomes second squared, and then the time will be the square root of 9 second squared. And what is the square root of 9? The square root of 9 is 3, and square root of second squared is second. So the time for that body to come to the ground is 3 seconds. So we can now comfortably get our range. We can now comfortably get the range. So the range will be equal to ux, as we said, times t, and that is r equals to the initial velocity of projection as we were given is 10 meters per second, and the time as we have gotten is 3 seconds. Okay, if we multiply this, the range will be equal to 10 times 3 we have 30 second per second, and second we cancel, we have 30 meters. So the range is 30 meters.